Very good morning, dear students and colleagues. Welcome you to the NPTEL course on Advanced Distribution System Analysis and Operation. And today we'll be focusing on transmission distribution interaction. All of you, please try to understand. As of now, we talked about the transmission system, distribution system, loads, generation, but also there is a strong link between your transmission system and distribution system. And probably you'll be very happy to know that current modern distribution systems has the capability not only to cater the load requirement of the customers, but also react or interact with the transmission system. So today we'll also come to know how the DSO and TSO do interact for the benefit of the overall efficiency of the power market. We'll be talking about concept of distribution system operator, DSOs. We'll also learn what are the mechanisms of bidding process within a DSO, what kind of ancillary support from the distribution grid to the transmission network. That means what kind of ancillary support may be provided by the distribution system to the transmission system, and what kind of transmission and distribution market mechanism do exist today. And then we will get into a case study demonstration on transmission and distribution interaction. And now let us focus on distribution system operator, which is quite a new concept, because in India, as of now, we do not have a real DSO in operation. However, in Europe, it is very, very popular, and you will find thousands of DSO operating. But in India, because DSO is nothing but an independent system operator for distribution system management, probably very soon we'll be experiencing the first DSO in India soon. Now, what exactly the DSO does? The conventional roles of DSO may be defined as it has the responsibility for connection and disconnection of distributed energy resources. So, DSO has the power or the authority to decide whether the distributed energy resources to be connected to the distribution network or not. Then further, it also decides the planning, maintenance and management of distribution network. It also looks after the management of supply outages, the challenges, and finally, it also looks after the energy billing for vertically integrated system. Now, currently, there are a few additional roles of DSO being added up, which are known as emerging additional roles for distributed system operators, in which we carry out peak load management through distributed energy resources. During peak requirement, how the distribution system can manage the peak load using those DRs available in the system. Network congestion management, if you are not able to evacuate the renewable energies due to the limited capability available to you within your distribution lines, then what kind of congestion management process need to be adopted. It also provides the reactive power support to TSO, because the transmission system, whenever there is a need of reactive power, probably they can expect some of the DSO to help to get into reactive power injection from the distribution system. And also procure voltage support. It takes care of voltage support to the system, and also looks after the technical validation of power market. So this is how actually the DSO normally operate. Now, there are a bit of actually regulatory framework to foster new DSOs. Let us focus on non-firm connection agreements for end consumers. So these are the connections agreements wherein the consumer agrees to have constrained power supply during peak hours, and the network fee is reduced as compared to firm connection agreements. So probably let's imagine I do have bit of rooftop PV with me, and I may sign an agreement with my DSO saying that as and when there is a peak requirement, peak energy requirement, I am ready to participate, I am ready to cooperate. That means my PV generation may be utilized by the distribution system So I do allow that kind of freedom to my DSO to take my energy as and when required. Okay. Now, similarly, bilateral flexibility contracts. So this refers to contractual agreements between DSOs and DRs owners to provide local system services such as voltage control, peak saving, and congestion management to the DSO. And the local market, and this refers to local flexibility markets for distribution system services in which distributed energy resources could participate to support the distribution grid. The output of this market could be technically validated by the DSO in cooperation with the TSO, that is transmission system operator. Now, what are the key benefits that one can get through a establishment of DSO or a successful operation through a DSO? First of all, it leverage data to increase RE penetration. Today, probably we are not very sure what would be the potential or the benefit that I can obtain due to my renewable energy integration or usage. So probably once you have a DSO system in place, then it will leverage a lot of penetration through renewable, or probably I can say the consumers will be encouraged to integrate renewable to the residential systems and also provide the excess power to the distribution system as and when available. Now, which also increase flexibility in distribution network. Now, today let's see, the distribution networks are very mild, where you just consume the power, but it doesn't allow any sort of reverse flow flexibility in engaging renewable energies as well as the consumers patterns, consumer consumption patterns. Whenever there is a peak, we have no idea what to do, what not to do. So probably the distribution system will be well managed through a proper flexibility mechanism when the DSO is in place. It also reduces network investment using DRs. Normally what happens when you look into a distribution system, what happens? The consumer's consumption is keep on increasing, and because of which the substation transformers are keep on loading. Okay, that means the capacity of the substation transformer is going to violate very soon due to increase in consumption pattern of the consumers. And then that means the distribution companies must invest to replace their substation transformers through a high rating transformer so that the consumer's requirement or the increase in load can be met. But the unfortunate part is that none of the distribution company will be happy to carry out their investment. So what would be the other alternate is that they can delay the investment of the substation upgradation by reducing the load through DR penetration. So please try to understand, once you integrate DRs or motivate people to have their own rooftop PV, for an example, so then the amount of power you draw from the high voltage network is reduced, am I right? And because of which your substation is not going to reach its peak, and probably it will reach its peak or maximum capacity in next 2 years time instead of today. So what you have done, the distribution company, because of the flexibility available to you for integration of DR, the investment for my substation got delayed by a couple of years. And that means reduced network investment using DRs. Hope you are able to understand. Please, read more literature to have more clarity on this issue. Now, what kind of flexibility that we can provide to the distribution network? DSOs could procure flexibility services such as voltage support, congestion management, peak saving, and these are the kind of flexibility the distribution system can enjoy through a DSO mechanism. So from the distributed energy resources that are already connected to the distribution network, facilitating in integration of the renewable energy. It may be achieved through the introduction of locational price signal in the distribution network. So we can also identify the locational price at each and every bus. That means if you inject 1 kilowatt of power at a particular node, then how much money to be paid to that consumer who has injected. And that kind of signal will promote and motivate people to try to invest some money towards their renewable energy integration to the distribution system. The establishment of the local market will help them not only for generation but also exchange energies. Okay, bilateral contracts are also a very good solution, because you can have your own PV parks and you can generate power if you have a good amount of land available, and if you want to invest in electricity market, so probably you can have a bilateral contract with an industry which is 20 miles away from your side or maybe 100 miles away from your location, so you can generate power at a particular point and get it back. So recently you'll be very happy to know most of the medium level industries, because the electricity cost is almost 40 to 50% of the manufacturing cost. So what they do, they establish their power plant, let's say 200 miles away in a very, very remote area, or wherever there is free land is available. So they invest there, inject power through a distribution network operator, and then extract it at the industry location where they do use. So that mechanism is also known as bilateral contract, and they are very short-term solution, maybe for a couple of hours that can be done, and are easier to implement with limited market participants. So today, this kind of concepts are existing in your transmission system. However, for distribution system, this kind of markets are not so common because of non-availability of a DSO mechanism. So once we have a DSO mechanism, probably this will be very, very easy for everyone to exercise as kind of small, low magnitude transaction between two consumers for a medium distances. The extra revenue for providing these flexibility services would incentivize the owners of the DRs to further deploy these resources. Once, if I have my own power plant and able to make business, then probably it will promote me to go for more or expand my solar park to further more areas to do more business with energy exchange, which in turn increase the flexibility in the distribution network. Now, as I told you that DSO grid planning, which talks about reinforce the grid, because first of all, whenever you plan a DSO, you must allow the distribution system to carry out proper planning. So the DSO can advise that what kind of reinforcement mechanism to be carried out. All of you, please try to understand, reinforcement of the grid means reinforcement of the substations, reinforcement of the distribution lines, each and every component that is being used between the consumer to the edge of distribution system is known as actually your devices or electrical components, and that all need to be reinforced. As I told you that, let's say I do have a 100 kVA distribution line, and I am very sure that this line cannot carry more than 100 kVA, but there is a power plant which is coming up in the lower point where more than 100 kVA need to be transmitted. So what I need to do, the only way out is either I reduce my generation at low end of renewable part, or I can increase the capacity of the distribution line so that the whole sort of distribution energy or renewable energy available to me can be evacuated by reinforcing my distribution system. All right. That is also a planning study. I know there is an area which is, let's say there is a desert, okay. We talk about Rajasthan. Let's say in the Jaisalmer side, we have a huge desert where huge PV parks are coming up. But if the distribution system is not capable of evacuating those generations towards the Jaipur city, then there is no fun, okay. So I think it is not only motivate people to go for renewable energy establishment or integration, but also the system, the distribution system or the distribution system operator must rest assured that the distribution network is capable of evacuating those excess energy available to me through, specifically through renewable energy. And to use flexibility services provided by the DRs, we can also offer non-firm access to their consumers or generations, and by optimally managing DRs across the distribution network and mandating them to comply with certain communication requirements and dispatch signals. Meeting peak load demand through local stored or generated energy instead of transporting generation from a distant source. Now, leveraging data to increase RE penetration. So, as you know that, in case of a normal classical grid that you have already seen, how do I leverage, people to penetrate energy through solar and wind, for an example, or maybe there could be a electric vehicle charging station where there are 100 charging points. So how do we really, or someone interested to have the own RE penetration to utilize for the electric vehicle charging mechanism? So such kind of concepts, I think it's necessary. So DSO must help providing information to both the consumers and the distribution companies to make sure that the RE penetration being motivated or encouraged. So DSOs can serve as the central hub, for managing consumers' data related to electricity consumption, production, billing, and location, as well as the type of distributed energy resources. So DSOs can collect and store this data according to the prescribed regulatory standard while protecting consumer right, including privacy. Using these data, DSOs can better forecast demand, leading to better planning and system operation. Such data also can enable greater deployment of renewable energy by helping consumers understand their consumption and or production pattern and make efficient decisions about their distribution network usage. Now, probably as I told you, so we need to have actually standards for data management and smart grid and digital technologies, improving communication with consumers, regulatory framework for future role of DSOs. So I think the DSO enablers, must have those features to not only operate a distribution system, encourage DSO, but also motivate consumers to be seriously participating and taking the benefit out of DSO mechanism. So there are few key facts that we can discuss. So key countries incentivizing the expanded role of DSOs. So especially countries in Europe as well as in the United States, they perhaps actually incentivize the DSOs. And then key transformational steps being taken by DSOs, that means deployment of smart meters, real-time monitoring system, creating a level playing field for aggregators, establishing local marketplaces. I think there is a new term that we have used as aggregators. So for the benefit of student friends, I just wanted to highlight aggregators are nothing but they are an agent sort of thing. Those who make a deal with a power company, let's say, and then decide the consumers who are willing to buy power actually, So they are the kind of central agent who coordinate between a group of generating companies and the group of industrial consumers, even for some extent high-end residential consumers. So key drivers for the transition: network capacity deferral, local congestion management, and need for voltage control. So key flexibility services being procured, demand side response, synthetic inertia, and then power quality, congestion management, voltage control, and reactive power support. So overall model framework, if you see what we do, that the new DSO functions, distribution market operator, DRM, long-term planning, as well as short-term planning. What are the opportunities? Innovation and DR monetization, new business models, and empowerment of utilities, consumers, producers, and third-party aggregators. And finally, the new benefits that we can experience is greater efficiencies and optimization, greater reliability and resilience, cheap electricity cost. Because you bring computation, probably the cost of electricity is expected to be lower, and then cleaner power because you motivate renewable energy to be participating, not only participating, but also aggression, showing aggression because of huge benefit that they see in near future, and then faster adoption of DERs and new energy economy. Just before going to the next slide, I just wanted to highlight, let's say today you as an individual interested to do business in electricity and you decided to go for a new PV park to be established and you like to sell the power. But what will happen when you go for a new PV park? the first thing will come up whether this energy can be evacuated through your nearest substation. So the distribution company, the gentleman will say no, because we don't have actually capacity for the transformer to evacuate your power, so we are not approving your proposal. However, whenever there is a DSO in place, the DSO will say no, look, the consumer is interested to give you energy. It is your responsibility to upgrade your substation so that the energy can be evacuated. So DSO is like a kind of non-profit organization, a kind of a someone who is in top of the distribution companies. So today distribution companies are everything, but once there is a DSO, a non-profit organization sitting in top of the distribution company, so normally they see to that the consumers' benefits are being taken care. And now, once you make your DSO effective, so what has happened? You're motivated, a lot of energy is coming up. So it may so happen that you may have excess generation available to you, or you may have a lot of ancillary services or support available to you that you like to transfer further to the transmission system. If the transmission system need energy at X location and the Y location DSO can supply some power which can further be catered to the X location or area 1 to area 2. So, it is always good that the DSO is not looked upon as an isolation body who has to handle only the consumer, but the other end there is a TSO sitting on top of DSOs, so they can also talk to each other and collaborate, so that the maximum benefit not only can come to the consumers through DSO, but the DSO also can get a lot of benefit by connecting it to TSOs. So, service procured by transmission system operator TSOs are being provided through DRs, typically connected to medium voltage and low voltage distribution network. Now, if there is a huge plant getting connected, let's say at 11 kV distribution system, or maybe at 33 kV distribution system, so probably that can easily be transferred to 132 kV, sub transmission system of the network. So, due to the relative scarcity of DRs today, the procurement is done with the assumption that the DS are fully capable of dealing with the resulting time varying power flows. Given the rising adoption of PV and BSS, which offer significant controllability, the level of services that can be provided by prosumers is rapidly increasing. Okay. So, what is happening today? So, consumers who are supposed to consume electricity, but today consumers are also producing power. So, those consumers are known as prosumers. So, in a distribution system, large penetration of DI alone can cause technical problems and challenges due to reverse power flow, such as network asset congestion and voltage exertions. So, these issues can be further exacerbated when controllable DRs such as BSS participate in provision of services. So, you can just have a look. So, this is how the DSO is sitting here and the TSO is sitting here, and these are the consumers. So, we have understood thoroughly how the DSO and consumers talk to each other, communicate to each other and exchange their benefits. However, now you are communicating to TSO. So, TSO is saying, DSO, look my dear friend, if you have any energy, please provide to me, and vice versa, because anyway the DSO is always taking help from TSO, but now TSO is taking help from DSO. So, there is an intelligence DSO agent which can communicate in both the sides to make sure that the overall consumers of distribution system and transmission system along with the industrial consumers benefited because of those coordination and exchanges of informations. Now, moving further, that in some countries like Australia, that firm limits on DR exports are being imposed to help to deal with this kind of challenges, such as how DRs can participate and BSS can participate, but they don't allow their participation cause a serious challenge to the system. While this could be a viable intermediate solution that allows DR participating in the provision of services and satisfying network constraints. Such traditional fit and forget approaches could also prove to be too prohibitive in the provision of services. effectively limiting the attractiveness of DR providing services through distribution network. And during the last couple of years, as you could see, an alternative for countries, regions, with open market, very important, is for the distribution companies to have an active role in managing DR services, especially for energy balancing approaches, ancillary services, demand responses provided directly by prosumers or via aggregators, while it's also incorporating network constraints. So there is a new role for managing this energy. So where you could see that we can have demand response mechanism where the consumers participate during emergency to help the distribution system, and also the aggregators may be coming to you and saying that, look, you please give your energy whenever there is an excess, and then they consolidate a group of people and then deal with the distribution company that at any given point of time I can give you X megawatt of power whenever needed. The new role is commonly associated with the term distribution system operator and has an objective, the efficient facilitation of DR services by making the most of the existing infrastructure without compromising distribution network integrity. Given that DSO will inherently affect the new way DR services will be provided, the new environment requires a paradigm shift in the way the transmission system and the distribution system interact. Consequently, having an adequate TSO-DSO coordination becomes crucial to ensure not only that the DSO role is fulfilled, but also the efficient operation of the power system as a whole, as I have introduced during my beginning of the lecture today. Thank you very much. Hope you have understood the concept of TSO-DSO. So the conclusion here is that you have distribution systems, they help their consumers, but when you have a distribution system operator, the consumers will be benefited more. It is expected to be, because of a lot of reinforcement. Management of distribution system is mandatory through DSO, so that the consumers can act as a prosumers and get benefited. However, once the DSO and TSO start talking to each other, exchanging information, so that both DSO, DSO as well as the consumers as a whole, the power system can operate efficiently. Thank you. Bye-bye.